So here we have solving systems of equations. We have two ways we're going to solve them. One is through substitution. In substitution, one of the equation needs to be solved for a variable. Then we're going to go ahead and substitute that equation into the other. Then once when we get our answer, we're going to plug our answer from step 2 and solve for the other variable and then write it as a point. Now through elimination, both our equations have to be in standard form. Once when they're in standard form, pick a variable that you want to eliminate. The only two things they have to follow is that they have to have the same coefficient and they have to have opposite signs. So you might have to multiply one of the equations or possibly both. Once when you have your solution for that equation there, you're going to go back and plug your answer into one of the originals and solve for the other variable. Now we do have two special cases. If all of our variables cancel out and you're left with a true statement, we're going to have infinite many. Same thing as saying all real numbers. Now, if all of our variables cancel out and we're left with a false statement, then we're going to have a no solution. So in our first example, we're going to solve by substitution. So we have both our equations here. Now we need to pick one of the equations and solve for a variable. I'm going to pick the second one and solve for m. The reason I want to solve for m is because 1, it's positive, and 2, there's no coefficient in front of it. So if I solve for m, it's going to actually equal, m is going to equal negative 3n plus your 13, because we had to bring that 3n over. Then I'm going to take this expression right here and substitute it into my other equation for m. So I'm going to have 2 times my negative 3n plus 13 plus your n equals 11. And then go ahead and distribute. And then combine like terms. And then we're going to subtract the 26. And then divide by negative 5. So n is going to equal 3. So this is only half of our answer. We're going to take this 3 and plug it back into one of our originals. Now what I'm going to do is I'm going to actually plug it into this one because that's what we're looking for is m, and it says m equals this. So I'm going to say, well, m is going to equal negative 3 times our 3 plus 13. So m is going to equal 4. So we need to write this as a point. Now usually our point is x, y. Even though they give us other variables, just go ahead and plug them in alphabetical order. So it would be 4, 3 in as a point. Now our second equation, we want to do elimination. Now the first part of our equation is fine, it's in standard form, but this one right here isn't, so we're going to have to move this 3y over. So I'm going to bring down my first equation, and then my second one's be 7x minus 3y equals that 4. Now we need to pick one of our variables and we have to eliminate one of them. I'm going to go ahead and eliminate the x's. It doesn't really matter, it could be x or y. Now on the x's, I look at 7 and 2. The one number they both go into is 14. So I'm going to times the top one by 7 and then the bottom one by 2. Now since they're both positive, one of these has to be a negative. I'll just pick the bottom. So we're going to take this number and distribute it all the way through the whole equation. So we're going to have 14x plus your 28y is going to equal 42. Then we're going to have a negative 14x plus 6y equals negative 8. So here our x's eliminate, so we're left with a 32y equals 32. And then divide by 32. Now what we need to do is take this 1 and plug it into one of these equations. It does not matter which one. So I'm just going to go ahead and pick the first one. So we have 2x plus 4 times our 1 is going to equal 6. Clean this up and then subtract our 4 over. And then divide by 2. So x is going to equal 1 as well. Now we have to write this as a point, so it'll be 1, 1, and there's our solution. Now our next example, we can pick any method we want. I'm going to go ahead and pick elimination because they're both in standard form. And I'm going to go ahead and eliminate the x's again. Now I have a 4 and a 1, so one number they both go into is 4, so I'm going to multiply the top one by 4. Now since they're both positive, I'm going to make this one a negative 4. So I should have a negative 4x minus 12y equals a negative 8. And then just bring down the bottom. So here our x's eliminate, our y's eliminate, so we're left with 0 is going to equal, and then our 8's eliminate as well. So since this is a true statement, we're going to have infinite many. Now we also have 3 variable systems. These ones, as long as you have an x, y, and z in every single equation, follow these steps, because if you try doing your own thing sometimes, you're going to start doing these circles over and over again. So what you want to do is pick the first 2, and we're going to eliminate the x. Then pick the bottom 2 and eliminate the x. Then we're going to have these 2 variable equations that we're going to go ahead and eliminate the y. Once we eliminate the y, we're going to have z equals some number. So we're going to take that z, plug it into one of our 2 new equations to figure out what our y is going to equal. Once we have z and y, we're going to take those 2 numbers and go back to one of our originals and solve for x. So let's walk through this problem. So here is the example. I'm going to take these 2 and eliminate the x's. Then I'm going to take the bottom 2 and eliminate the x's as well. So these are my first 2. So this is my a and my b. So we want to eliminate the x's. So I have a -4 and +2. We're going to times the bottom one by 2. So just bring down the first equation. And then distribute that in +2. So you got 4x minus 8y plus your 12z equals 32. So my x's eliminate. Then I have a -6y plus your 9z is going to equal 42. So now, this is one of our new equations. We're going to hang tight on this one. Now over here, this was my b and my c. So we want to go ahead and eliminate the x's. Now since they're both the same coefficient, opposite signs, we don't have to multiply anything, so we can go ahead and just solve it here. So these eliminate, and we're left with 2y plus 4z is going to equal 28. So this equation here and this equation here, we're going to eliminate the y's from. So here they are right here. So we're going to eliminate the y's. We have a -6 and a +2 times the bottom one by 3, so we can go ahead and get rid of those y's. So I'm going to bring down the first equation, and then we're going to distribute that 3. So we have a 6y plus 12z is going to equal 84. So my y's cancel. I have a 21z is going to equal 126. And then divide by 21. So z is going to equal 6. So this is 1 out of 3 of my variables. We're going to take this, plug it into one of these. Once again, it doesn't matter which one. I'm going to go ahead and pick the bottom one. So we got 2y plus 4 times 6 is going to equal 28. Clean this up. And then we need to subtract the 24. And then divide by 2. So y is going to equal 2. So now we have our z and our y. So we're going to take both of these, and what we have to do is go back to our original problems and plug it into one of these. I'm going to go ahead and pick this first one here, which I have it right here. So we have a -4x plus 2 times our y minus 3 times our z is going to equal 10. So we just need to clean this up. We got -4x minus 14 is going to equal 10. So add the 14. And then divide by -4. So x is going to equal -6. So now we have all of our points, and we have to write as a point. So we're just going to go x, y, z. So we have -6, 2, and +6. And there's our solution.